Hey there, welcome back you beautiful people, and today we will discuss about queue. Now what is a queue? Queue is an arrangement where the first element would be served first and the last element would be served last. So that's one thing. Moreover, if we check this image, this is a queue of people. The first person would be served first, right? And the last person would be served last, which is cool. Now if a new person needs to be added in the queue, the person needs to come and stand at the end of the queue. Now no one can stand in front of the queue because that's not the rule, and when the first person is getting served, the first person will leave the queue. So pretty simple rule, right? So let's proceed further and check this very simple diagrammatic presentation. And a queue is first in first out list. Now first in first out is also known as FIFO in short, which is first in first out. Alright, so this is cool. Now FIFO list is a queue where we have a specific rule of FIFO. So it is nothing but a list where we apply the rule of first in first out. Alright, so that's one thing. Now in this particular queue, the remove operation would be done in front and the add operation would be done at rear or at last, which we have already seen, which is the generic rule of a queue. Alright, so let's proceed further and check a couple of types of queue which are available in Java, and this is a very high level explanation because there are some combinations of these types as well. So first type is array backed queue, a queue which is implemented using array in the background by Java. Likewise, there is a linked list backed queue where a linked list is used to save the information in the background by Java. Then we have blocking queue. As the name suggests, the blocking queue will block some elements. What are these elements? These elements are null values. In blocking queue, we won't be able to add null elements, so that's blocking queue. Then lastly, we have the priority queue. Now priority queue is a queue where elements would be arranged based on natural ordering or based on comparable interface and the logic which is implemented in the class itself, or providing the comparator object. Plenty of downloads there, right? Now don't worry about priority queue. It seems to be difficult, but it isn't. Alright, so that's one thing, and we will take a separate video on priority queue as well. Let me quickly navigate to Java docs now. Now friends, here is the Java doc for queue interface, and if you simply Google for queue in Java, you will get the first search result, which is cool, right? And in here, if we check, there are multiple classes, there are multiple sub interfaces, and if we check, there are many type of queues, right? Now friends, the basic high level type of queues I have already discussed. There are a couple of queues which are based on array. There are a couple of queues which are based on linked list. Now what is the difference between linked list and array is something which we have already discussed. Now friends, if your program is more into operations and in your program there would be multiple operations on the queue itself, then making use of linked queue is a better option. And if you would like to get fast access in the data, then array queue is good. Then we have some blocking queues in here. Blocking queues are the queue where we won't be accepting null values. This is again we have checked. Then finally we have the priority queue. Priority queue will sort the elements beforehand. Alright, so these are the high level types, and we have some methods in here: insert, remove and examine, and we have multiple versions for specifying or performing these operations as well, so we will check that as well. Now friends, I will suggest you guys to check this documentation. This will help you out. And now, without wasting any time, let's navigate to Eclipse and let's code in a program based on queue. Alright, so let us get rid of this auto generated stub, and in here I will type in queue equals new linked blocking queue. Now we will also get options for DQ. DQ is something else, and in fact we will take a separate video for checking out DQ. Alright, so now let us import the required packages real quick. Alright, so this looks good, and in here it is giving us some warning, and this warning is queue is a raw type. So let us fix that, and this queue would be based on integer. Alright, so this is good, and now let us add couple of entries. Dot add, and we will add 1. Alright, then let me copy this line of statement and paste it a couple of times, and I will add 2, then 3, then 4, then 5. Alright, so this looks good, and then we will make use of a for each loop for integer element colon q, and in here we will type an element. So this is cool, and we would be able to see the list properly. Here is the output, which is perfect, right? Now friends, in this example, this queue, linked blocking queue, is backed by linked list, as the name suggests. Now in linked list, the size could be dynamic. We can add as many as element we want, but in place of array, the size is constant. We need to provide the size beforehand. So in here now we will make use of a array backed queue, and there we need to provide the size. So in here, let me type in array blocking queue, and as soon as we do this, in here we need to pass the argument. For example, the size of the queue is 6, right? So let me execute the program. Again, the program will work properly. Now let me add in a yet another element in the queue, and it would be like 6. Now what would be the outcome? Definitely there won't be any issue, and it will work properly, because this parameter 6 is the size of the queue. Maximum 6 elements could be there in the queue. Definitely there could be lower number, there is no lower limit. There could be 0 element in the queue, there could be 5 element in the queue, there won't be any issue. Now for example, let me try to add in a yet another element in the queue. This would be the 7th element. As soon as I execute the program, there would be a crash. Let me show you the crash, and it would be queue full crash, right? And if we check what is the exception is illegal state exception. So let us do one thing. Let me copy this name of the exception, and let me copy all of these statements. Let me right click and surround this with try catch. Here we go, and the exception would be of type illegal state exception. So as a result, as we are handling this exception using try catch block, first 6 element would be added successfully, but there would be a exception shown. The exception is shown because we are printing the stack trace. Let me do one thing. In order to show it in a more delightful way, let me give a statement which will say queue is full. Now this is good because at least our program is not crashing, and we are giving a proper output, which is cool, right? Now in here there is a yet another catch. For example, before adding any element, if we for example try to remove an element, then what would be the outcome? So in here I will type in queue dot remove. Then what would be the outcome? Let me show you. In here again there would be a crash, and the crash would be no such element exception, because definitely no such element is present in our queue. So again, let me surround this with try catch, and let me paste in the exception, no such exception. Alright, so we need to add in the required package, and let me copy and paste the statement in here, and we will say queue is empty. Alright, so this is cool, right? And if we check the output doesn't make any sense, but at least we are able to get a proper output. Now moving forward, let us quickly check the Java docs. Here we go. Now in Java docs, if we check, there are basically 3 operations. First one is insert, then we have remove, then we have examine. Now what is add or what is insert and remove is something which we know. Insert will add an element at the end of the queue, remove will remove the first element from the queue, and examine will check the first element if it is available or not. So pretty cool, right? For examination we have element method and peek method. For insert we have add method and offer method. For removing we have remove method and poll method. Definitely these 3 methods, which are add, remove an element, will throw exception, and offer, poll and peek will return some special value. So how to handle the return value is something which we will see in couple of minutes. First of all, let us check the usage of element. Now first of all, let me add in a sysout statement, and inside sysout statement if I type in queue dot element and then I execute the program, then at last we will get 1, because 1 is the head of the queue. For example, the first element is updated by 10, then the last statement, this statement will return 10, right? Let me add in a message as well in order to reduce confusion. Alright, so this looks good. So what is the first element in the queue, which is 10. Now for example, before calling in this element method, we remove a element, then definitely which element would be removed? The first element would be removed. So I type in queue.remove, then this particular statement should give us the output as 2, right? Let me show you. So here is the output, which is perfect. Now for example, we try to call in queue.element method before adding any element in the queue, then what would be the output? This particular statement will throw an exception. Let me show you. If now I execute the program, there is a exception, and the exception is no such element exception. Definitely we can again surround this with try catch, and then at least we would be able to perform the operations, which is cool. But this program is ugly. There is a jumbled up code. Now in place of add, remove and element, we will take help of offer, poll and peak. Let us do one thing. Let me get rid of all of these stuff which is not required, and let me remove this as well. Alright, so in place of adding these elements, we will make use of offer, right? So in place of add, let's make offer. Let me copy this particular keyword and paste it real quick. Here we go. So this looks good, and now if I execute the program, definitely there won't be any exception. Now there might be a question in your mind that these method, in fact this particular method offer, will return some value. What this value would be? For example, if I try to check what would be the return type or what would be the return value when we are successful, then the value would be true. Now let us check what is the output where we have a failed transaction, where we were getting the exception. It would be false as expected, right? So this is cool. Now moving forward, let us do one thing. Let us make use of the poll method. Now poll method would be used to remove an element, and we will perform this operation on an empty queue. So in here, let me remove an element beforehand, before adding any element in the queue. So I will type in queue.poll. Right, and this will return null because there is no element, right? And if we perform the remove operation after add operation, then definitely this will return the element which has been removed from the queue. Here is the output. So 1 is removed from the queue, and in order to identify whether the remove operation has been done successfully or not, let me add in a separator, and once the remove operation is done, let me rerun this loop, and now you will able to see the outcome. Before from 1 to 6, and then we removed 1, and then the elements are from 2 to 6. Right, so this is the usage of poll method, and usually offer, poll and peak method are better suited in the programming environment where we need not to worry about the exceptions and we handle the return types accordingly. Now lastly, let us check the usage of peak method, which is the last method in fact. So in here again, let me type in sysout, and in between the parenthesis of println, we will type in queue.peak. And if we execute the program, this will again return null. And let me add a separator real quick once again. If I cut this particular method and a statement from here and paste it in here, then the output would be 1 because it is checking out the first element in the queue, and the first element is 1. It found it, so it returned it. Alright, so this is cool, and this is the basic operations of queue, and that's it for today. Thanks for watching.